All right, well, welcome back. Here we are, chapter 8, moving right along. So this chapter that we're going to start off the new year with is all about similarity. And so we're going to be looking at similar figures and, more importantly, similar triangles. The first section that we're going to talk about, section 1, really is just kind of a review of what ratios and proportions are. So this should be pretty nice for you guys. Let's start off with the definition of a ratio. A ratio is just considered a comparison of two or more numbers. And there's two different ways that you can write a ratio. One of them would be the side to side, 8 is to 3. The other one, your ratio can be written as a fraction, 8 is to 3. I don't care which way you use, it's just that certain problems will lend themselves better for one way to the other. A proportion is when you take two or more ratios and you set them equal to each other. For example, say we had 1/2 and we had 5/10. If we were talking about this as a proportion, we wouldn't be talking about them more as fractions, but more as ratios. So we could say 1 is to 2 as 5 is to 10. And you can see that this ratio right here would simplify down to 1/2. So that makes sense that they are the same. So what can we do with proportions? Well, proportions are usually used with problems where you're trying to solve for a specific missing variable. For example, what if I had this proportion? I had 3 is to x as 7 is to 8, and we want to figure out what x is. So once you set up this proportion, if you recall from your basic math classes that you've had, we can cross multiply. So we can take the x and multiply it to the 7, and that will equal the 3 multiplied to the 8. So we end up getting 7x equals 24, and then when we solve for x, you get x is 24 over 7. So this number down here didn't necessarily have to be an integer. It could be a fraction, which is fine. So those are ratios and proportions. So let's talk a little bit more about proportions. We have terms of a proportion, which we really need to know. So if we set up our proportion like this, we're going to have a fraction over here, and we're going to have a fraction over here. Both the numerator and denominator of each of those fractions are called something specific. So this first spot right here in the upper left-hand corner, that's your first term. The term below it is called the second term of your proportion. Up here is the third term of your proportion, and then of course down here would be the fourth term of your proportion. So on top of being able to number them first, second, third, and fourth, they also have specific names. So the first and the fourth terms of a proportion are called your extremes. And then the second and the third terms, which are kind of like in the middle, right, in between the first and the fourth, those are your means. So don't get the word mean confused with average. These are the means of a proportion. Okay, so we get to the first of two theorems that we're going to talk about today. One of them, it's Theorem 59, talks about the means extremes product theorem. So if we go based off of the name of this theorem, you can kind of guess what you're going to be doing. You have the means and you have the extremes, and we know product means to multiply. Well, what this is, it's just a very fancy way of saying that you can cross multiply, which we already knew. So yay. So let's see exactly in general terms what this is looking at. We have A is to B as C is to D. So you can take your extremes and your means, multiply them together. So here are your extremes multiplied, here are the means multiplied, and you get this equation. Okay, so A times D equals B times C. Awesome. Now, just to confuse everybody, there's Theorem 60, which is the means extremes ratio theorem. So this theorem and that theorem, very similar, they just have one word difference. The word is ratio versus product. So remember, product means multiply, so that's the cross-multiplying theorem. The means extremes ratio theorem says that if you start off with this equation, that you can actually come up with many, many different ways of writing your proportion. So one of them would be the typical one that we had up here. A is to B as C is to D. But think about this. If we look at this proportion where I have A is to C as B is to D, when you cross multiply, the A and the D are still being multiplied together and the B and the C are still multiplied together. So you can imagine there's a lot more variations that you could do where that would still be the case. What this theorem allows you to do, it allows everybody to have their own way of looking at a problem and coming up with their proportion. And everybody's going to be the same. It's going to be correct no matter what, that when you cross multiply you get the same answer. Okay, so you just have to make sure that things are going together the way that they should. Okay, so don't get the means extremes product theorem confused with the means extremes ratio theorem. Got it? Good. Okay, the next, we've got geometric mean, which the book likes to confuse people and call it the mean proportional as well. Isn't that lovely? Okay, so either way, when they're talking about geometric mean or mean proportional, they're talking about a time when the means are equal in a proportion. So what does that look like? Well, think about this. If you had 1 is to 4 as 4 is to 16, the 4 is in both of the means locations, the second and the third term. So they're the same. So that's a geometric mean. So we would say 4 is the geometric mean or mean proportional between 1 and 16. So what they're going to ask you to do is something like this. Find the geometric mean between two numbers, 3 and 5. It's actually a very easy problem to set up, knowing that the 3 and the 5, those are your extremes, and the geometric mean is what we're looking for. It's the same for both spots, so we put an X in both of those spots. Now using our means extremes product theorem, we can cross multiply, and we get x squared equals 15. Taking the square root of both sides, we get x equals plus or minus the square root of 15. And yes, if you can simplify the square root of 15, you would. We can't, so we won't. But what you do have to remember is your plus or minus sign. A lot of people will forget the plus or minus sign, and that will be your careless mistake for the quiz or the test. So don't let that be you. Okay, so whenever you're taking the square root of both sides in an equation, you have to remember your plus or minus sign. Okay, that's it, folks. I hope that wasn't too bad for the first time out after our nice long winter break. We will be practicing a lot of computational problems with this section. Don't worry, there'll be proofs to come. I know you're very sad about that, huh? Okay, bye-bye.